In this question, it is told to us that let under root x3 minus x2 whole square plus y3 minus y2 whole square is equal to this plus this. You have to find which of the following is true. It is given that it is a multiple answer question. Let a be equal to x1 y1, that is, let the coordinate of the point a are x1 y1, b x2 y2, and c as x3 y3. It is easy to see that this thing denotes the distance between the points b and c. That is, this equation shows that BC is equal to AC plus AB, or we can say BC is equal to CA plus AB. That is, I can say that ABC are collinear with A point somewhere between B and C. And because B, A and C are collinear, it means I can say slope of BA, slope of AC, or slope of BC all are equal. And see the first choice. First choice can be written as y3 minus y1 upon x3 minus x1. And if I take x2 minus x1 on right hand side, I get y2 minus y1 upon x2 minus x1. That is, left hand side will become slope of AC and right hand side will become slope of AB. And because slope of AC and slope of AB are equal, hence I can say first is correct choice. Similarly, second choice can be written as y3 minus y2 upon x3 minus x2 equal to y1 minus y2 upon x1 minus x2. That is, second choice can be written as y3 minus y2 upon x3 minus x2 is equal to y1 minus y2 upon x1 minus x2. That is, after transformation, left hand side will denote the slope of BC and right hand side will denote the slope of AB, and they are clearly equal. Therefore, second, similarly third, all the three are equal. Hence, I can say all the choices are correct. Note that in such type of questions, if it is given that more than one choice may be correct, in that case you will say first, second, third, fourth all are correct. But if he says only one choice is correct, in that case you will mark that choice as correct choice, which is the best possible choice, and best possible choice in this case is all of these. In this question it is given that among the three lines this and this, two are equations of two altitudes of an equilateral triangle. Then the centroid of equilateral triangle is. The meaning of the question is, these three lines are given to you, and out of these three, two lines are altitudes of some equilateral triangle, and you have to find the centroid. It is clear that in the case of equilateral triangle, angle between any two altitudes is, looking here, I can say angle is 120, and as we know that if this is angle between two lines, this is also angle between two lines, and actually angle between two lines means acute angle between two lines, and if this is 120, then this will be surely 60. That is, I can say that angle between any two altitudes in the case of equilateral triangle is 60. Obviously, angle between this altitude and this altitude is surely 60 degree. It is not difficult to see. You can see very easily slope of this is minus 1 by root 3, slope of this is 1 by root 3. Tan theta equal to mod of 1 by root 3 minus 1 by root 3 upon 1 plus minus 1 by root 3 into this is equal to 2 by root 3 upon 1 minus 1 by 3, that is equal to root 3. That is, I can say the angle between these two altitudes is 60. Otherwise, directly also we can see very easily that slope of this is minus 1 by root 3 means, and the line is clearly passing through origin. Therefore, the diagram is sure to be of the type this, where this angle is 30 and slope of this is 1 by root 3 and passing through origin means this line is of the form this, x equal to root 3y and x equal to minus root 3y. That is, this is also 30 degree, and this 30 means this 30, and angle between the two altitudes becomes 60 degree. Hence, out of these three, clearly these two are the altitudes, and the point of intersection of these two is clearly origin. Hence, origin becomes the correct answer. In this question, he is asking that if ABC are related by this equation 4a square plus 9b square minus 9c square plus 12ab equal to 0, then the greatest distance between any two lines of the family of lines this is, you have to find the correct choice. The given information itself means for all the values of ABC which satisfy this equation, all those values of ABC, if I put in this equation, I will get two family of concurrent lines. That is, I mean, one family will be of this type and second family will be of this type, and you have to find maximum distance between two lines, out of which one line belong to this family, other line belong to this family. First, let me find both the family of concurrent lines. Clearly, this equation can be written as 2a whole square plus 3b whole square plus 2 into 2a into 3b minus 3c whole square equal to 0. That is, I get 2a plus 3b whole square minus 3c whole square equal to 0. That is, I can say 2a plus 3b plus 3c into 2a plus 3b minus 3c equal to 0. That is all the values of ABC which satisfy this given equation, which will make left hand side as 0. For all those values of ABC, either this part will be 0 or this part will be 0. Those values of ABC for which this part is 0, those values of ABC will represent one family of lines, and those values of ABC which satisfy this part, those values of ABC will represent second family of concurrent lines. See why? Because this can be written as 2 by 3a plus b plus c equal 0, and this can be written as minus 2 by 3a minus b plus C equal to 0. And this clearly implies that the line of the form ax plus by plus c equal 0, that will surely pass through the point 2 by 3 comma 1. That is, for different values of ABC, the different lines you will be getting, all those lines will be surely passing to the point 2 by 3 comma 1. And the values of ABC which satisfy this condition, for those values of ABC, the line of the form ax plus by plus c equal 0 will represent another family of concurrent lines, and point of concurrency will be minus 2 by 3 comma minus 1. Comparing this and this, we can see. Hence, I can say that one family of concurrent lines is of this type, second family of concurrent lines is of this type, and the point of concurrency here is 2 by 3 comma 1, and second family of concurrent lines has point of concurrency as minus 2 by 3 comma minus 1. It is clear that whichever line I take from this family and any line I take from this family, if those two lines are non-parallel, they will surely cut somewhere. Hence, the distance between those two lines will be 0. But take that case when a line of this family and a line of this family are parallel, and those two lines are perpendicular to the line joining these two points. That is, one line is of this type, other line is of this type. For these two lines, distance between the lines is maximum. But if I take any other line, one belonging to this family, other belonging to this family, and even if they are parallel, the distance between them will be less than this distance. Hence, maximum distance between a line of this family and a line of this family is distance between these two points, which is, that is 2 into 2 by 3 whole square plus 2 into 1 whole square. That is equal to under root 16 by 9 plus 4, that is 2 root 13 by 3. Hence, I can say B is the correct choice. In this question, he is asking that the equation x cube plus y cube plus 1 equal to 3xy represent, you have to find the correct choice. Choices are, this equation represents the three sides of a triangle which is not equilateral. Second, this equation represents three sides of an equilateral triangle. Third, this equation represents a line and a point. Fourth, none of these. If you see carefully, this is of the form x cube plus y cube plus 1 cube equal to 3x into y into 1. And we know that a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. That is, we know that this is also equal to a plus b plus c into 1 by 2 a minus b whole square b minus c whole square plus c minus a whole square. Hence, I can say this is equal to 0 means either a plus b plus c is 0 or a, b, c all are equal. And keeping this concept in mind, because this equation can be written as x cube plus y cube plus 1 cube minus c into x into y into 1 equal to 0. Hence this means either x plus y plus 1 is 0 or x minus y whole square plus y minus 1 whole square plus equal 0. And this implies that x is equal to y equal to 1. And because these are scalar quantities, hence these are all greater than equal to 0. Therefore, sum equal to 0 is possible only if this is also 0, this is also 0, this is also 0. That is x equal to y equal to 1. And this clearly represents a line, and this is clearly representing a point. That is, I mean to say, all the values of x and y which will satisfy this equation and x equal to y equal to 1 will satisfy the given equation, and the values of x and y which satisfy this condition equation, they will lie on a line, and this clearly represent a point 1 1, and this is 1 1 is clearly not lying on this line. Hence I can say this equation represent a line and a point. In this question, he is asking the locus of point of intersection of perpendicular lines are one belonging to this family, other belonging to this family is. The meaning of the question is there are two family of lines represented by first equation, which is x plus y minus 2 plus lambda into 2x plus 3y minus 5 equal to 0. And other family of concurrent lines is this, that is 2x plus y minus 11 lambda into x plus 2y minus 13 equal to 0. That is, one family of lines is this, other family of lines is this, and he says that I take any one line of this family and I take that line of this family which is perpendicular to this line. That is, for example, if I have taken this line, then I will take this line and the two lines are perpendicular. That is, I always take those two pair of lines which are perpendicular, and in this way I can find infinite number of pair of lines, and you have to find the locus of point of intersection of the two perpendicular lines. Keeping this concept in mind, that in a circle every angle in a semicircle is always 90. Therefore, it is obvious that because every line of first family is passing to this point, and every line of second family passes to the point this, and this is the point of intersection of these two lines, and this is the point of intersection of these two lines. Because these 2 points are fixed, only the lines are varying. One line is varying in this way, other line is varying in this way. Only condition is angle remains 90. It is obvious that locus of this point will be a circle for which these 2 points will be working as end point of diameter. Hence I can say correct choice is A.